Hello guys, Jagvir Singh back with another video of Mastercam 2022, and in this video I will show you how to do the programming on the part that we designed in the last video, which was part 1 of wireframe to solid model. So let's get started. So in this particular video I will first of all show you how to make the programming in terms of the basic programs, and I will also use various planes in order to align the part in such a way that EDM is possible as well, because I can see few of the operations can easily be taken place on the EDM itself. So what I'm going to do is I'm just going to have two separate videos, one for a simple contours and machining, and the other setup that is going to be on based of EDM in another video. So let's get started with this one first. So we can see that this is the part that we are willing to make or manufacture in real life. So what I'm going to plan is, first of all, we can do facing. We can chop off some extra material to have a clear path. Then I can have this particular shape that is kind of a tangent. I can add some fillets before that. In previous video I already had fillets, but in this video I just was trying something on these. So in selection and 0.25, that's good enough. There we go. So yeah, so you can see this part can roughly, the most material could be taken out by simple materials, by simple operations as well. If I just take out the contour, I can get, if the stock material is rectangular, and then afterwards I can just simply move the part and align it in such a way that I can use a wire EDM to chop off all the excess material. I can make holes with the drills and also a simple end mill roughing operation or even contour, and yeah, then I'm pretty sure we can get this part easily made in just two operations or two setups. There are different ways as well. You can make this part in some other ways, but to have the better finishing, because you can see there are sharp corners right here, which is really hard to get to the finishing of, because every tool have a radius on it. So how I will do is, I will show you right now. I will go to machine, I will go to mill, default, then I will run to the properties as soon as possible, files, all the parameters are fine. I'm just going to name it as 1111. From material, that's my specification. Assign tool number sequentially, on of duplicates, override default all tick mark, because we want to have clearance height, retract, and also feed plane. Material, let's say I'm going to keep it 6061 for now, and stock setup, there we go. So bounding box, that's what I'm going to use. I'm going to select the entire material or the part, and it's going to give me all the dimensions. I'm going to click OK. I'm going to keep 20 thou above the stock, and I'm also going to add some extra material. So I have 5.7, the closest one. Generally I like to add 1/8 on both the sides, so it's adding a quarter, so I can make this about 6. Then 2 is around 225, and 1.42 I can keep it as 1.75. that would be good enough. 0 on the X, 0 on the Y, and 20 thou for the Z. So the reason why I kept 20 thou on the Z is because of this particular reason, because you can see above the origin I've kept 20 thou for the facing operation. Make sure before you start any programming you go to your planes, and everything, your all construction and all T planes are in your top, and then you pursue. So now we can actually get started with the programming itself. The very first operation is going to be facing. Just simply click on face, click OK, select the tool. Obviously it's going to be the face mill for facing. Select library tool, automatically we have face mill. Single click, click OK. you can I'm just going to keep the numbers to be the same. So these are the predefined values that Mastercam is giving us to work with. If you know these values, you can work according to that as well. I'm just going to keep 40. I'm going to keep the spindle speed to be like 4000, plunge rate around 10, depending on all the machine and also the tools that you're using. Very important. Cut parameters one way, because our part is really small. This part is really small in terms of dimension. So what I can do is I can also go in one pass. I'm pretty sure about it. Approach distance 50%, 50, or you can also reduce it to 25 depending if you want to save some time. That's the only thing, or a little bit of difference that is going to make. The stock to leave on floor should be always 0 because we don't want any material. Depth of cut, you can turn it on or just keep it off, all depending on you, because we are just going to try to chop off 20 thou. Anyways, it's going to cut in one pass. Link in parameters, click on the clearance, use clearance. This will save a lot of time if you're going to put it on loader or repeatedly. Put all of them on absolute. Then we have top of stock to be 20 thou. Feed plane is generally 100 thou above the stock. That is rule of thumb. So which is going to be 0.12. Retract is about 100 thou above the feed plane. Almost the same value that we already have, which is 0.25. All of them in the absolute that I tend to keep. Go to plane, all of them should be on the top plane. Turn on the coolant and click OK. So here it's showing that tool diameter is not large enough to face the entire part in one pass. Alright, it's because it's trying to chop off this way, and the length of the part, because the part is aligned according to the length, the y-axis is according to the length. So what we can do is, I'm pretty sure there must be an option of aligning it in. Yeah, I think this is the option. I click 90. I'm not sure, but I'm guessing. Yeah, there we go. So what I did there is I just simply changed the auto angle or rotation angle or roughing angle, you can say, 90 degrees. So instead of the tool trying to cut this way along the x-axis, it just moved its position by 90 degrees and it's trying to cut along the y-axis now. And that's why it was possible rather than me changing the parameters. I can just have a quick look. Rather than the tool coming from this side along the x, now it's cutting along the y-axis. And you can see, and that's one pass because the thickness is small. There we go. We can just save it. So now what we are going to do is we can also have the contour right here. Make sure the entire material is cut out. Now, yeah. So there are a couple of ways of designing these kind of parts. You can also think in very different ways. But the way I'm thinking is like eventually I'm going to be using EDM to cut these materials and also this slot in between. If you're just going to use a normal end mill and other tools, and if you don't have EDM or other wire operations, then it's going to be a little bit time consuming, and also a lot of different planes are going to be used. And what I will what I'm thinking right now is to make two different files and upload, just to help you guys to understand what are the two different ways of designing the same part and manufacturing it, and whichever is more convenient for you or to understand or to use, you can work accordingly. So right here I'm going to click on contour to get extra material chopped out, and solid chain or wireframe. For this case I'm going to keep it yes, but I'm going to turn on the plane on the levels for the wireframe, this wireframe in particular. Regenerate a little bit, not an issue. So the wireframe, I can just simply use it and click on geometry and add the wireframe right here. There we go. This as well, and click OK. The arrow is outwards. I want the arrow to be inwards, chain side, and also the direction is going to be reverse. There we go. Oh, my bad. Wait a sec. I want to get the outer material rid of. Alright, so chain side and the direction is fine. Yeah, that looks good. Now I'll go to the parameters and change it. Tool. I'm going to have 1/2 inch bull. That's what I'm going to use. 1/2 inch, 0.5, 1/2 inch, 0.0625. There we go. Round 40, 4000, and what I can say is 10. Rapid retract, cut parameters, computer, everything. Depth of cut should be. So this is the contour that I'm using for roughing. So there is going to be decent material to be chopped off. So 0.25 is good enough. Half of the tool diameter. I'm going to keep lead in lead out to be 25%. My bad. 25%. 25. 25. Move it on the other side. 0.1. Breakthrough. Sure, why not? To be 0.1 as well. Multipass no. Lead in parameter. Linking parameters. All absolute values. Make sure. Feed plane 0.1. Top of stock should be 0. Depth is going to be the entire depth, the very finish. That's it. And also what you can do is you can just be particular about making sure if you want to go all the way out. That's why I added some material. You can add more. You can add quarter, and then also make this to be 1.5 instead of, I mean, all depends on whatever, how much material you want to cut it out. Eventually not going to make huge difference, but still better to have that. You can see right here it is going all the way through, and also slightly of the additional material is being chopped off as well. Now what I can do is I can do the same thing on the side for the finish, because I left 10 thou that I'm assuming on the walls. So for first one I'm going to leave 10 thou for finish, for roughing, and the second one I'm just going to copy this one and paste it right there, and just going to change just one parameter, that is stock to leave on floor on wall to be 0. So in the first one I kept 10 thou, in this one I'm keeping 0. So I have 3 operations. I'm done with this main side. So now I have these holes that I need to work with. So this is basically a countersink that I need to make sure that a counterboard that I need to make sure that how to get this one done. So for now we have a proper shape. I can show you how will it look like when I go for the verification for this particular kind of frame, and I go to verify NCI data processing, and I'm going to turn on the collision and also the color loop. I'm going to reduce the speed slightly. This is going to be really fast, and you can see, there you go. Don't worry about this material, because in reality this thing is not going to exist. It's just going to chop off, which it looks good. So we have this entire material, and we want to have holes as well. This side we have the counter bore, and the this side is through. So that's what I'm going to do right now. I'm just going to make a simple drill. That's what I can start with, obviously, because right now we are on this level for now, and going all the way through that dimension in the very first operation is going to be really too much for any part. So what I will do is I will simply make a center drill for both of them first. Come to a drilling, go to drill. It's asking for what are the holes. I'm going to say okay, this is the dimension first, 0.85, and then what's going to be the other one, that is going to be this one, 0.9. Whichever way it is. Tool I'm going to specify, I will be using center drill. So this is my first center drill. Feed rate, I'm not concerned about anything for now. I'm just going to make sure, that's what I want to make sure is the linking parameters are good, all the values are in absolute, top of stock should be 0 for both of them, and then the depth I can specify to be the entire, that was around negative 1.5 and going, but this is center drill, sorry about that, this is center drill, so it's going to be negative 0.25. Just I'm going to have a little bit of marking for as a pilot, so that I can use drills to actually drill out the excess material in the other operations. Retract I can keep 0.2. Clearance I don't need to keep for that long, but that's fine. Top of stock should be 0, good enough. Tip compensation no needed for now. Coolant on. Yep, just the top. It's just going to have insert a little bit of material, not a lot, and it looks good to me for now. You can also verify it once again. There we go. Just a little bit of the tip is going in, so that we have the bores made. So now next step is actually going for a drill operation. I can simply copy this, copy and paste it there, copy and paste it. The entities are going to be the same. So what I can do is, I know that this one is 0.85 and is going all the way through, and this, the smaller one, I can analyze the entity of the smaller one is 0.65, 0.65 and 0.85. So what I'm going to do is I'm going to have both of them the same, but so because 0.65 is a smaller one, so I'm going to use 0.65 for both of the holes, but it's going to work as a pilot drill for this particular big hole. So what I'm going to do is just make a pilot drill. I'm going to do the same thing, just change the parameters and the drill size. 0.65 is a smaller one, so I can just look for the tools, look for the drill in particular, drill 0.65 in diameter or whatsoever we can get, not equal, or I would say between 0.6 to 0.7. Alright, okay, we can use 0.625 5/8 drill, that looks good. Going to have all the other parameters to be fine, nothing else is going to change. The only thing that is actually going to change is going to be the depth this time, which is going to be through all, which is I'm going to keeping it to be negative 1.5, and the tip compensation is going to be turned on. The breakthrough is going to be about 0.25, basically a quarter. Plane all top, coolant on, click OK. There we go. So now it also depends on your visualization, that is really important, because you need to make sure that what material is chopped off and what material is still on. So that is the holes, so those are two holes that I made through all, that looks good. So I know that I have one counter bore and this thing is it still have a lot of material here which I just need to chop off till a certain depth. But now I can make sure that I can chop off that particular material as well. So what I'm going to do is, for this particular one, I will make another drill operation, and it will satisfy this hole, and it will be end of this side, and then afterwards come back here and make a pocket for making that particular wireframe. I'm just going to show you what I mean. It might be slightly confusing to understand what I'm trying to do right now, but I'm just going to simply copy and paste this thing again. Oh, I think all the operations got selected. My bad. Delete these. Delete it. Delete it. And delete it. There we go. Just going to copy and paste Bactrill. Change the entities. I need that one. I don't need this one. I'm going to delete this one and say okay. 0.85 is the one that I need. 0.85. That's the size of the drill that I'm looking for. If I don't have a drill, then eventually I have to make a pocket or something else. Equal to 0.80, 0.85. I don't think so there exists any drill, so eventually I'm not going to make a drill operation. I'm just going to keep a simple, I can use either a contour, or I can also use a pocket or even a slot if I want. Pocket looks good to me. I can use half an inch end mill or quarter inch or 5/8 or 3/8, whichever I want to be precise. I want to have this hole, plus I want to have, so I'm going to do one by one. This is through all, so it will have different values, and depth value, basically the Lincoln parameters are going to differ. So the tool right here I'm going to be using is half-inch bull. I can use that. 0.5 is less than 0.85. I'm not going to change the parameters, you can have according to yourself. On wall is going to be 0, on floor it should be 0. I'm just going for one pass, that's it, nothing else. Step over I'm going to keep around 25%, entry motion around 20%, and Z clearance, that is slightly more, way too much, 50 thou. So the tool is half inch, I can keep it to be more, yeah, 125 is good enough. Finishing, I'm just going to keep one finish pass of around 10 thou, and lead in lead out 25, because remember we don't have a lot of space. It's 0.85 and the tool is going to be 0.5 itself. I think it might not work just for the fact that we are trying to chop off a lot of material in one shot, so we have to see how it works. Clearance all absolute, just like I said, that's what I prefer. Top of stock 0, feed plane 100th above that. Depth I'm going to keep negative 1.5. Planes coolant, I'm not sure if it's going to work because of that, but yeah, it did, looks like it did. Alright, I'm going to basically copy and paste the same thing, copy and paste it, and then just change the wireframe right here for the bigger one, and change the parameters by a slide. Everything else is going to be the same. The linking breakthrough is going to be turned off, this one. Everything else is going to be the same. Linking parameters, top of stock is going to be 0, yeah, that's fine. Depth is going to be till here, there we go. coolant on, that's off. Good enough. So now we can verify it once again how it looks like. Alrighty. Alright. Alright, there we go. You can see, yeah, this is what I was looking for to do it with this operation. So now all we need to do is chop off this material right here, the lines that you can see, and also this particular block, and we will be done with this part. So for in this video I'm just going to show you these operations. The next video I will upload is going to be EDM wireframe, and also like if I get some time I will also tell you some other ways how to manufacture this part without an wire EDM, because that's going to take a lot of other operations. We can, if we want to, we can just chop off this extra material, we can have roughing operations, we can set up another plane in this way and make a tool pass in such a way that we get rid of this extra material right there, but we need to make sure that there are sharp corners in this part. Cutting with any CNC tool is going to be giving a rad, so it all depends on if those kind of specifications work, then that's not an issue. If they don't, then EDM is the only way to go. So thank you for watching this video, and do not forget to subscribe. Stay tuned for the next part. Take care for now. Bye.